Today we're going to be graphing some absolute value functions, and although I will show you how to do it by hand, I will also show you how to use the graphing calculator to make things a little bit faster for you. We're going to graph y equals the absolute value of x, y equals the absolute value of x plus 2, and y equals the absolute value of x minus 5. The parent function for an absolute value graph is y equals the absolute value of x. That means that that's the basic generic function. No special things added to it or subtracted from it. And we're going to figure out what the number on the outside of that absolute value does to the graph. In order to graph by hand, it's important to know that there are certain things that happen to the absolute value. The number that may be in front of the absolute value does something, the number inside the absolute value changes the graph somehow, and the number outside of the absolute value changes the graph somehow. In order to graph by hand, we're first going to find what's called the vertex. The vertex is the value hk. It's the opposite of what's inside the absolute value bar and exactly what's outside. So we're just looking at these two values. After we find the vertex, we're going to create a table of values, plot the points, and then connect those points in a sharp V. It's good to know that the absolute value graph is in the shape of a V. So for y equals the absolute value of x, I would first find the vertex, and I'm going to put the vertex in the center of my table of values. So I'll have two numbers above and then two numbers below. So for y equals the absolute value of x, there's nothing inside the absolute value bar and there's nothing outside, so that means that it is 0, 0. So when I plug 0 in, I get 0 out. So 0, 0 is the vertex. Then I'm going to pick two numbers that are smaller than this x value and two numbers that are larger than this x value. So two numbers smaller would be -1 and -2. Two numbers larger would be +1 and +2. So now I have y equals the absolute value of -1, which gives me 1, and y equals the absolute value of -2, which gives me 2. Y equals the absolute value of 1 is 1, and y equals the absolute value of 2, which is 2. So I've got these points to graph. And when I do graph those, it would look something like this. So this is the parent function that we would compare all of the other graphs to. See, the next one that we want to look at is y equals the absolute value of x plus 2. So what we're doing here is we're adding 2 onto the parent function. That's going to change each of my values. So now I have new things to graph. I would have -2, 4, -1, 3, 0, 2, 1, 3, and 2, 4. So graphing those points would look like this. So it appears to me that graphing y equals the absolute value of x plus 2 raised my graph 2 units. Next, we're going to look at y equals the absolute value of x minus 5. And I subtract 5 after I take the absolute value. It's going to change my values again. So 2 minus 5 would give me -3. 1 minus 5 would give me -4. 0 minus 5 is -5. 1 minus 5 is -4. and 2 minus 5 is negative 3. So this one would look like this. So it appears that subtracting 5 outside of my absolute value moved it down 5 locations. So what does it look like this value does to your graph? This gives it what's called a vertical shift. If it's positive, it moves it up. If it's negative, it moves it down. And these were the 3 graphs. Now we're going to see what happens with the value inside the absolute value graph. So you're going to follow the same steps. You're going to create a table of values after finding the vertex, plot those points, and make sure that it's a sharp V. So the vertex here would be 0, 0 for your parent function. The vertex here, remember I said it's the opposite of what's inside, exactly what's outside. And the vertex here would be the opposite of what's inside, exactly what's outside, because there's nothing added on these. Remember that the vertex goes in the center of your table of values. Pause the video, graph, and then double check to make sure that your graphs are accurate. So y equals the absolute value of x is still our parent function. Whenever I have y equals the absolute value of x plus 2, it shifts it to the left 2 units. And when I have y equals the absolute value of x minus 5, it shifted it to the right 5 units. So what happens is the number inside changes it the opposite direction. So y equals the absolute value of a times x minus h plus k. The opposite of h is the direction it's going to move. Then we have another value. What happens if we put a number in front? Again, create your table of values, pause, and then double check your answers. The number in front gives it what's called a vertical stretch. It pulls it up and makes it skinnier. If it is a whole number, if it's bigger than 1, it's going to make it skinnier. If it's a negative number, it flips it upside down. And if it's less than 1, it's going to make it a wider graph. So in summary, the h value tells you if you're going to shift left or right. You'll shift left if it's a plus h. You'll shift right if it's a minus h. The k value tells you to shift up or down. And the a value tells you if the graph opens positive or negative, so if it opens up or opens down. And it lets you know if the graph is going to be wide if that number is less than 1, or narrow if that number is greater than 1. And we're looking at this a value for that. The negative is not part of the less than 1. The negative tells you it opens down. The value of a is what's going to tell you if it's wide or narrow. up.